Hello children, welcome back to our chemistry class. So today we are going to discuss chapter and exercises from the chapter The Periodic Table. Let's move into the questions. Question number 1 is, which of the following statement is not a correct statement about the trends when we going from left to right across the periods of periodic table? So the first option is the elements become less metallic in nature. We know that when we move from left to right across a period, the elements are becoming less metallic in nature. We can see we move from metals to semi-metals to non-metals, right? Therefore, that statement is correct. The number of valence electrons increases. So, that is also correct. When we move in a period, we know that the number of valence electrons one by one increases as their atomic number increases. Okay? And the atoms lose their electrons more easily. We know that metals lose their electrons more easily while non-metals gain electrons, isn't it? Therefore, when we move from left to right across a period, the tendency to lose electron decreases. So that statement is not a correct statement. Let's move to the fourth statement. The oxides become more acidic. So we know that metal oxides are basic in nature, while non-metal oxides are acidic in nature. So, when we move from left to right across a period, the basic nature of the metal oxides become weaker and they will become more acidic as we move from left to right. So, the answer is C. The atoms lose their electrons more easily. Hope you understood. We'll move to the next question. Question number 2. Element X forms a chloride with the formula XCl2, which is a solid with a high melting point. So from that statement itself, high melting point means it is an ionic compound, right? So ionic compound means X would be a metal. Okay, now the question is, X would most likely be in the same group of the periodic table as. Here sodium is there, magnesium is there, aluminum is there, silicon is there. So, 3 of them are metals and silicon is a metalloid. But we know that from the formula XCl2, the valency of X is 2. When we write the chemical formula, we know that the valencies should be exchanged, isn't it? Therefore, the valency of X is 2 and chlorine is 1. Okay. Therefore, which element among this is having valency 2? It is magnesium. So, X would be most likely in the same group of the periodic table as magnesium. Let's move to question number 3. Okay, question number 3. 5 questions are there. Each one is a one-word question. So, which element has? You have to name the element. Okay, 2 shells, both of which are completely filled with electrons. So, only 2 shells are there. Both of them are completely filled. That means 2, 8. Which is that element? Atomic number 10, neon. Okay. Second one, the electronic configuration 282. 282 means atomic number will be 12. Therefore, it is magnesium. A total of 3 shells with 4 electrons in its valence shell. Therefore, the electronic configuration will be in this way, 284. Total 14, isn't it? Atomic number 14 means silicon. Okay. Then a total of 2 shells with 3 electrons in its valence shell. So only 2 shells are there. In the outermost shell, 3 electrons are there. Therefore, 2, 3 is the electronic configuration. Atomic number 5, it is boron. Twice as many electrons in its second shell as in its first shell. So we know that first shell maximum capacity is 2. So the double of that first shell is there in the second shell. That means 4 electrons will be in the second shell. So 2 plus 4 is 6. So atomic number 6 is carbon. Okay. So let's move to the answers. Here you can see neon, magnesium, silicon, boron and carbon. Alright. Next question is question number 4. What property do all elements in the same column of the periodic table as boron have in common? One more question is there. What property do all elements in the same column of the periodic table as fluorine have in common? Okay, boron is atomic number 5. Therefore, electronic configuration will be 2, 3. So all the elements which are coming in the same column or the same group of boron will have 3 valence electrons. Therefore, their valency will be also 3. Okay. And when we move into fluorine, we know that fluorine is having atomic number 9, electronic configuration 2, 7. Therefore, all the members of the group fluorine will have also 7 electrons in the valence shell, and their valency is equal to 1 because they will always gain one more electron. Hope it is clear. We'll move to question number 5. An atom has electronic configuration 287. What is the atomic number of this element? So we know that totally 17 electrons are there. Atomic number is 17. Therefore, it is chlorine. Okay. And to which of the following element would it be chemically similar? Atomic numbers are given in parentheses. Nitrogen, fluorine, phosphorus and argon. We know that all the atoms in the same group will have same number of valence electrons. So among this, we know nitrogen is electronic configuration 2,5, fluorine 2,7, phosphorus 2,85, argon 2,88. So among this, fluorine is having an electronic configuration 2,7, which is similar to the electronic configuration of the given element. That means chlorine. Okay. So chlorine and fluorine will come in the same group. They are chemically similar as their valence electrons are equal.